तो इसे आप इंटरेक्ट करिए और इसी मतलब फॉर्मली आपको डिस्कस भी करेंगे और मतलब ब्रीफ में एक प्रेजेंटेशन भी देंगे। ठीक है,
चलिए, थैंक यू फ्रॉम ओके good afternoon. So thank you for interaction. We are the learners. So if you ask the question, that is the better for us, and we can elaborate the things more better way. In from last 1 week, you are knowing about the what is the solar pump based agricultural applications, particularly the solar pump. So my presentation is based on the solar pump, but it is more about the not particularly the solar side, but how the solar pump working and the performance, as well as the what are the factors we have to consider in the pumps, and what type of pump is required particular case or particular situation. So that is the today's topic. And except this, you may ask any other questions regarding the just suggested you. If you want to ask about the biofuel, renewable energy, engine applications, then we can discuss. Okay, so all from the compatible in the both Hindi and English. Okay, so we will discuss in brief about the what is the solar pump, then we will what are the pumps generally we are using. So so this is the outline of the presentation. First, we will discuss about I am affiliated from the NIT Srinagar, so we will discuss a brief introduction about the NIT Srinagar. Then the solar pump. I think from last 1 week you well aware about the solar pumps, but these pumps are generally two types. One is the centrifugal pump, another is the submersible pump. Generally, the more feasible, or you can say the economical as well as the sustainable point of view, the submersible pump is more aligned to the solar energy. Another thing is the pump performance in terms of the either in centrifugal pump or in submersible pump. Finally, the advancements in the pump technology, what are the we can what is exactly the output of this conferences, if we implement in the effective way as well as the sustainable way, then that is the purpose will be solved of this workshop. So first of all, I want to discuss about the NIT Srinagar. NIT Srinagar is the oldest institute in this region. It is established in 1960. It is the third REC of the country, and it is developed in the second 5-year plan. When the after the independence, it is the one of the oldest institute which is situated in the this valley. Another important part is it is converted into the Institute of National Importance, or NIT, National Institute of Technology, in 2003. Then we got the Institute of National Importance 2007. Finally, it is working under the Ministry of Education, or previously it is the MHRD. It is a central funded institute, and we have the 8 BTech program, UG program in engineering, and 11 MTech, as well as MSc in physics, mathematics, and chemistry. Along with, we have the some research organization, like we have the some center of excellence. 6 centers are there: water resource center, as well as the central research facility. We can work on the all area of the engineering. So we have the central facility, another facility for the computer service center, as well as we have the some center for the maintenance, as well as interdisciplinary branches like the renewable energy. iDream is there. So there are the more than 162 is the faculty in engineering, and as well as the some 50 or 50 54 faculty in the allied branches. So more than 200 faculty is there, and along with we have the these are the achievements currently. We have the 79th rank in the engineering category. In engineering category, more than 10,000 institute participated in every year. So we have the 79th rank, and India Today ranking we have 19, and along with we have more than 120 crore 100 projects, 90%, 99% faculty retention, and few consultancies also there. We are providing the consultancy for the JNK, particularly road transport or the electrical and canal, hydro. These are the some area we are providing the consultancies. Now we come on the solar power of the sun. It is sun is over there, so you know well aware about this. Dive into the captivating technology behind the sun, or we can harness the sun energy into the water applications like the pumping or the irrigation system. So the application make the solar pumps game changer for the renewable energy application. You heard about from last 1 week, the Kushum Yojana is launched in India, and most of the agricultural farming is done by this. But lot of innovations is required in this direction. So we are here, and we will discuss some technology aspect in this regard. So solar energy, you know that the harnessing of the sun, it is the sustainable solution. We can the energy we can acquire, or you can say achieve this power continuously when we are in the cities, in the area where the electricity available, the area where is not it is away from the these infrastructure, then we can use this energy anywhere, any part of the earth. Another part is the important part is the photovoltaic effect. So photovoltaic effect occurs when the photons in the sunlight excited the electrons in the semiconductor material and generating the electrical current. So the basic theory is PV, photovoltaic effect. And what happened, the energy comes, or the sun energy comes on the panel, and it will be excited the semiconductor material or PN junction type panels, and they will provide the electricity. Finally, the main role and what are the research is going on, the research is in terms of the photovoltaic panels efficiency, or the photovoltaic panels convert the portion of solar energy radiation is usable electricity. It is the important area in terms of the PV, because currently we are achieving only 15 to 22%. So this is the area we have the scope, more than 80% energy we can increase. So what type of the technology is required, and how convert maximum part of this sun energy into the electricity. So that is the important thing we will discuss. So as you know, the PV panels, photovoltaic panels that convert the solar energy into electricity, and another important part come in this solar power system. You know about, well aware about it, that is the DC motors. Direct, if we want to convert direct this energy into the mechanical energy or the pump energy, that is the more feasible. So DC motors that provide power the water pump using the electricity generated by the PV panels. Another part is the pump. So pump is the mechanical component that converts the electrical energy into the kinetic energy, or finally it can, you can say in other words, it is the pressure energy of the mechanical means in terms of force. So force is, if you want to discuss about the pressure, that is the force upon area. So exactly we are converting the pressure energy of the electricity finally it will be harness, or you can say supply the energy into the different applications. The energy come on the panel, that will be you can run with the submersible pump, and you can store this some altitude, and you can apply this energy or water for the different applications, for not only the agricultural, you can apply anywhere this part of application. So it is the one of the important aspect where the submersible pump is more feasible. In this case, we can put the submersible pump in the well or bore well, then that power is converted into the pressure energy, and pressure energy is supply the water from bore well to the up to this desired position that can use for the different applications. So the basics of the solar pump. The basics of the solar pump is harnesses the power of the sun. Exactly what is the meaning? We are seeing that it is the solar pump because it is the harnessing the power of sun. So in this case, the clean and renewable energy sources eliminate the need of fossil fuel. Generally, our agricultural system is based on the diesel or any any other type of fuel, or in some extent where the electricity is available, the pumps or motors are electricity based. But if both options are not available, then we can use this solar pumps, as well as the electricity or the fuel fossil pumps both are not feasible solution or sustainable solution. After 20-30 years, the fossil fuel will be a very costly, or you can say it is not available in the earth. Day by day, the fossil fuel means diesel or crude oil is depleting, and after 30 or 40 years it will be deplete. So one area you can use the energy, sustainable source of energy, that is the solar energy. So slowly we all of the country, or you can say the whole world, is transferring the our power system or harnessing systems are on the solar base. There are some challenges are there, but finally we can achieve this energy if the efficiency is 10 or 15%. There is no harm, because it is the abundance, it has the lot of energy is available. So in the key component, we can say the solar pump system, there is the some wiring control and con some controller system are there, wiring systems are there. Then it will combine solar pump, solar panel, wiring, controller, that will be define the whole solar pump system. So these are the main components. First is the lift or delivery, how much head is required to supplying the water, and what is the ground level of the water. So on the basis of that, first parameter is pump utilizes the mechanical energy to DC motor to lift the water from the source and deliver it to the desired location. So that is the first part. You can say the discharge, you can say the lift, or the delivery. Another part is the pump performance. So pump performance, pump efficiency, and pump performance means pump output, that is in terms of the discharge or head, will critical factors to minimizing the overall system effectiveness and water output. So this is the important things. Another important thing to utilizing the solar pumps or the pump technology. At the end, what is the role being an engineer, or our the purpose of this? We want to customize is as per the our requirements. So the solar pump can be designed and selected to match the specific water requirements and site conditions, ensuring the optimal operation conditions or UK operations. So this is the main part we will discuss in later part. So these are the two types of pump generally we are using. One is the centrifugal, another is submersible. So centrifugal, it work on the centrifugal effect, or you can say the force. Centrifugal force is the main driving component, or you can say the element which can transfer the water from lower level to desired location. So centrifugal pump are the crucial component of many industrial and agricultural application, efficiently moving fluid and converting the rotational energy into the pressure or flow. So that is the main principle. We will explore in the fundamental working principle, design, performance, and as well as the versatile nature of this pump. Generally, the submersible pumps are growing in stage, but finally, if we see about the total pump technology, most of the pump is centrifugal pump. If we using in our houses, there are the partially is the submersible pump, but most of the applications we are using the simple centrifugal pump. The basic components are the impeller is the important part, another is the casing, another part is the suction and discharge, or these are at the discharge, and there is the nozzle is there, and shaft and bearing. So these are the important component of the centrifugal pump. We will see some small video on this technology, and finally we can being a mechanical engineer, what is the role? The role is that design or modify the bend geometry, rotational motion, and fluid dynamics. These are the important part of the engineering point of view, and we will see what are the effect if the geometry, bend geometry, or the impeller geometry will change, and what is the effect on the discharge, what is the effect on the head, or you can say the head means the height where we want to supply the water. So we will see a small video here.
You can get more Gossip Taco. Simply click on the link in the video description down below to find out more.
So look at here.
Centrifugal pumps come in many shapes, colors, and sizes, but they typically look something like this. The pumps consist of two main parts, the pump and the motor. The motor is an electrical induction motor which allows us to convert electrical energy into mechanical energy.
Everyone know about it, but generally the concept is we think this is the whole pump. Only one part is the centrifugal pump, a small part is the pump, and another part is the driving, that is known as the motor. So motor and pump, these are the two things, but we are discussing only the pump here. However, the motor is important part, and that important motor part will be replaced by the electrical power will be replaced by the solar power or solar energy. That is the important concern, but rest part is same.
This mechanical energy is used to drive the pump and move the water. The pump pulls water in through the inlet and pushes it out through the outlet. As we take the unit apart, we can see that we have a fan and a protective casing mounted at the back of the electrical motor. Then inside the motor we have the
दिख रहा है
stator.
ना क्लियर
The
रिफ्लेक्शन
stator
इज
holds the
तो नहीं आ
copper
रहा है उसका
coils.
लाइट का.
Let's look in detail at that a little later in this video. Concentric to this, we have the rotor and shaft. The rotor rotates, and as it rotates, so does the shaft. The shaft runs the entire length from the motor and into the pump. This then connects into the pump's impeller. Some models of centrifugal pumps, like this one, will have a separate shaft for the pump and the motor. Separated shafts are joined using a connection known as a couple. Coupled pumps will usually have a bearing house which, as the name suggests, houses the bearings. The shaft continues into the pump casing. As it enters the casing, it passes through a gland, packing, and a stuffing box which combine to form a seal. The shaft then connects onto the impeller. The impeller imparts signal.
So three important part is there. One is the casing, where the that it is nothing but it is the only the covering, but it covering have also some design aspect is there. It will also work as a source of to rise in pressure energy. Another main important is the rotor, or that is known as the impeller here, and this impeller is connected through the shaft, and the shaft is derived from the motor. So motor takes the energy either from the electricity or either from the PV panel. So that is the main components. So
Centrifugal force onto the fluid, which enables us to move liquids such as water through a pipe. The impeller is enclosed within the pump casing. The casing contains and directs the flow of water as the impeller pulls it in and pushes it out. Therefore, we have a suction inlet and a discharge outlet. At the back of the electrical motor, we see that the fan is connected to the shaft. When the motor rotates the shaft, the fan will therefore also rotate. The fan is used to cool down the electrical motor, and it will blow ambient air over the casing to dissipate the unwanted heat. If the motor becomes too hot, the insulation on the coils inside the motor will melt, causing the motor to short circuit and destroy itself. The fins on the outside perimeter of the casing increase the surface area of the
Being an engineer, if we want to start in this area, that is also an important part. If we supply the electricity, there is continuous heat is generation will take place due to the mechanical motion. So this heat will be transmitted through the atmosphere, that is fine. If it is not, that accumulation will take place, and at the end the winding will heat and maybe the burning will take place. So this fan and the fins are required in this uh, motor part. Another part, the pump is also cooling is required, but this is the electrical part. I am skipping this induction and all the things.
and insert them into the stator of the motor casing. This will create the effect of a rotating magnetic field. At the center of the stator, we place the rotor and
This is
shaft.
the electrical part,
The rotor
comes
will
from
be
the
affected
electricity.
by the rotating magnetic field and will force it to also rotate.
Induction
The
effect
rotor
is there.
connected to the shaft, and the shaft runs from the fan through the rotor all the way up to the impeller. This way, when the rotor rotates, so will the impeller. So now, by creating a rotating magnetic field within the motor, we spin the rotor, which spins the shaft, and this spins the impeller.
I think
Looking at the
working is
pump
clear.
casing, we find
What
a
is the
channel
exactly
through
going
which
on the
is flowing,
centrifuge?
which is called
Now
the loop.
the technical
This
part.
fluid spirals around the perimeter of the casing up to the pump outlet. This channel increases in diameter as it makes its way to the outlet. The shaft passes through the seals and into the pump casing, where it connects to the impeller. There are many types of impeller, but most will have these backward curved vanes, which will either be open, semi-open, or closed.
These are the different type of impellers are available. Maybe more other classifications also there, but in general, if we purchase any pump, centrifugal pump are there, the closed, semi-open and open. Say closed means both side the impeller is there. Semi-open, one side is plate and another side plate, and another type is open. Simple, there is no plates are there, surface is there.
These backward curved vanes do not push the water.
Backward curve
The curved
vane are
edge
used in the
outer
pumps.
edge moving in the direction of the expanding balloon. These vanes will provide the fluid with a smooth path for the water to flow. We'll see that a little later in this video. The impeller is submerged in water. When the impeller rotates, the water within the impeller also rotates. As the water rotates, the liquid is radially pushed out in all directions to the
ये
edge
बंद
of
कर
the
दूं मैं
impeller
थोड़ा सा.
and into the balloon. As the water moves outwards off the impeller, it creates a region of low pressure which pulls more water in through the suction inlet. The water enters into the eye of the impeller and is trapped there between the blades. As the impeller rotates, it imparts kinetic energy or velocity onto the water.
So this is the centrifugal
By the time
effect.
the water reaches
When
edge
the
of the impeller,
rotate,
it
then
reaches
the
very high velocity.
four particle is moves outside or
This
peripheral.
water flows off the impeller and into the balloon, where it hits the wall of the pump casing. This impact converts the velocity into potential energy or pressure. More water follows behind this, so a flow develops. The balloon channel has an expanding diameter as it spirals around the circumference of the pump casing. As it expands, the velocity of the water.
There are the two things. One is you can see the blade. A blade, you will see this expansion will take place. Here, area is less, slightly it is increasing. So what happened? What is the purpose of this? The purpose of this, we want to increase the Venturi effect. The effect is like this. So there is the one famous equation of the fluid mechanics, continuity equation. Area and the velocity, or you can say the discharge is constant. If the mass flow rate is constant, it is based on the mass energy conservation, or that in case if the area is less, the velocity is more. If area is high, the velocity is less. So this concept is applied, and the same concept is applied on the casing also. Here you can see the casing area is less, and continuously when it goes to the discharge, the area is rising. So the from there, if the enter water from this eye and when passes to this discharge, the area is continuously expanding. So what happened, the kinetic energy of this pump और दिस इम्पेलर जो रनर है या इम्पेलर है, इसका जो टोटल एनर्जी था जिस स्पीड से मोटर रोटेट कर रहा था, वो टोटल काइनेटिक एनर्जी इज कन्वर्टेड इनटू द प्रेशर एनर्जी. सो दिस इज द होल कॉन्सेप्ट.
Decrease, resulting in pressure increasing. This expanding channel therefore allows more water to keep joining and converting into pressure. So the discharge outlet is therefore a higher pressure than the suction inlet. The high pressure of the discharge allows us to force the fluid through pipes into a storage tank or around the pipe system. The thickness of the impeller and the rotational speed affects the volume flow rate from the pump, but the diameter of the impeller and the rotational speed will increase the pressure it can produce. Centrifugal pumps are represented in engineering drawings with symbols like these.
These are the symbolic representation in the engineering. Box पे आपको दिखाई देंगे.
NBSH.
It is another important part. If you want to work on the pump, then that is another important part in the, if you are discussing about the centrifugal pump, if you want to procure or purchase or install the pump, that is the net positive suction head, NPSH. This is the important head. If you want to install, for example, if you install the pump here, so you have to know what is the ground level of water and what is the level where you want to supply this water at the roof or at any other building. So net positive suction head is important part. There are the two major classification, NPSHR and NPSHA. So please see the video.
Which is the acronym for net positive suction pressure. We'll briefly cover what this means. There are two letters at the end of the acronym, the NPSHR and the NPSHA. The R is the required NPSH. Each pump is tested for this value, and this can be obtained from the pump manufacturer by the pump operating chart. Don't worry about this confusing looking chart at this point. We're going to break it down and cover that in detail in a dedicated video. Links to that in the video description down below. The R value is basically a warning or danger point. As the water enters the pump and flows into the impeller's eye, it experiences a loss of energy due to the friction. This will give us a pressure drop. At certain conditions, the water flowing through this section can reach boiling point. When this occurs, we refer to this as cavitation. We're going to see more on that in just a moment.
There are two important part has been discussed here. One is the net positive suction head. In general, if you want to supply the of water from 100 meter, for say 100 meter, so 20 meter is below the ground level and 80 meter is from the pump upper level or the discharge side. 80 meter there and 20 meter the ground. So total 100 meter is the NPSH. It count in the suction head as well as the delivery head. Another important part, that is the theoretical value, but in actual there are the losses in the mechanical or the rotation or the bend or the pipe friction or the pipe fittings. These are the losses. So we have to consider two things. One is the required, another thing is available. Required is 100 meter but available is less, then fine. If the then we have to see available head is more practical case, and if you want to 80 meter available head, then required is 100 meter, then how can supply the water? That pump is not work. If available is 120, required is 100, then it is can apply. So this is the important part, the technical part you have to understand. If you want to procure any pump, then it is the important.
The other letter was the A, and this is the NPSH available. This depends on the installation of the pump and needs to be calculated. It considers things such as installation type, elevation, liquid temperature, liquid boiling point, etc. The available pressure should always be higher than the required value.
So this is the important term.
If we have an installation and we calculate the NPSH-A as 11, but the pump requires an NPSH-R of 4, then the pump should be okay. However, if we install a pump and require an NPSH-R of 13, then the available NPSH is insufficient and cavitation will occur. So what is cavitation?
another important thing, it is another issue which is occur in the pumps, only the centrifugal pump. So the centrifugal pump is obsoleting, or you can say it is not feasible in every condition. The submersible pumps come into picture. The important loss is the cavitation. So cavitation we will discuss in the future in the forthcoming slides. Now come on the our presentation again. So this is the important terminology we have discussed here. Now already discussed what is the main components. Components are the impeller, casing, shaft, or there is some issue उस पे स्क्रीन पे शायद हुआ है कुछ. So in technical side there are the three types of heads are there. One is the velocity head, another is the pressure head, and that will define the energy conservation. Velocity head means the kinetic energy which is fluid represented the velocity and converted into the pressure head, because it all things, or you can say the all engineering concept work on the law of energy conservation. And energy neither can be created nor be destroyed, it will be always remain same. If some part of energy is converted in another head, so the same concept is applied here. What exactly going on in the pump? We are supplying the electrical power or the power from the PV panel. That energy is converted the rotational power means kinetic energy, and that kinetic energy is converted into the pressure energy. So this is the whole concept on the basis the pump is working. So energy conservation important part, but in terms of we want to see the parameters is the speed, flow rate, and pressure. Speed means the kinetic energy available. If you some pipe jet has the more penetration depth, or some have the very less, so that depend upon the kinetic energy. If kinetic energy is more, then the jet of the water will go further, or you can say the from more distance, but the speed is low, it will be dropped at the lower positions. Same the another important part is the discharge, or you can say the flow rate. It is important part. Farmer point of view or agriculture point of view, more important part is the discharge, because we want to work on the forms or the simple farm level, or you can say the plane surfaces. So the flow rate or discharge is important part. Another thing is the pressure. Pressure means how much depth is the bore well or the bell. That is important part. If we bore well is more, so the more pressure is required in the submersible pump or this pump. Important part is another part is cavitation. Cavitation is nothing but when water head is more, NPSH is greater than the required NPSH, then what happened? The water will not come, because the suction side is air, or the partially the pressure head NPSH is less, then it will be suck some part of the air. So the air bubble enters in this, and these air bubbles when come in the pipes or casing, it may be a collapse, and the kinetic energy is more in this. When it is collapse, it will be strike on the surfaces, and this strike is very high intensity or high pressure. So it will be damage of the pipes, either casing or impeller blade or supply line. So this is the important part. The air bubble drops, pressure की वजह से form हुआ है, and then the formation will be collapse due to the motion or discharge. So the collapse of these bubbles can cause a localized high pressure region and leading to the pitting and erosion of the impeller surfaces. So that is the one of the issue which is generated. So the cavitation is not required. However, the efficiency is also dropped. Mechanical point of view, if you want to see the discuss in the discharge and the flow rate, that also we will reduce, because the some part is the only the imaginary, or you can say that is not actual part. There is the air is there, so the flow rate will discharge, but that is more concerned in part of the performance point of view, because it is the pitting will take place, the surface is erode or surface will damage, then the flow will disturb, the energy rise in pressure energy will disturb. So performance degradation is the one of the part of the cavitation. So cavitation can significantly reduce a pump efficiency, flow rate, and may even cause the complete pump failure. That is the one of the reason. If it will be damaged, then failure will take place. So before going the submersible pump, you first see another important part.
Don't worry, we're going to go through them step by step and start from the basics. Each type of pump has a different chart, and the data plotted on them also varies with the model.
Being an engineer, if we want to install the pump, so what is our role? Integration is not our role. Technology part and the performance part is our role. So if you suitable pump is required, what type of pump is suitable in particular condition, what type of conditions is arises, how can install that pump in the better power output. The solar panel is small solar panel can run sufficient of water, but only the thing if we install the actual or desired pump. So these are the parameters we have to see. In the Kusum Yojana, only you can say the Kusum plan of the solar pump, they are using the DC motors, and DC motors is based on the submersible pump.
That on the main vertical y-axis we have the head pressure, and on the vertical x-axis we have the flow rate. Basically speaking, the head is
in terms of the pump is concerned, there are the only two parameter, and if you want to the performance or efficiency, or you can say the installation, then these two important parameter we have to look after. First is the head, or head means the pressure. Head means pressure, simply in terms of simple language, the pressure. Another is the flow rate or discharge. So if the power output of pump is defined by the formula rho QH, rho is the density of water, Q is the flow or discharge, H is the head. So this is the power of the any pump. So this power can define in the performance curve.
The flow rate is how much water the pump can move. So what do these charts represent? If we turn the pump sideways and connected it to a pipe, the pump is pushing the liquid horizontally. So there is,
if the pump is pushing like this, that is the maximum discharge will come out. There is no head, height is not there. So maximum energy is applying for the supplying the water. So maximum discharge will take place when the pump is horizontal. When the head is rising,
but the water is flowing at its maximum flow rate. As we slowly rotate the pump towards the vertical position, we see the flow rate decreases but the pressure increases. That's because it's now pushing against the water and the friction. As we get all the way to the vertical position, there is zero water flowing out of the pump but maximum pressure. And that's because it's using all its energy.
So if you are using the maximum head, then what condition arises? The condition, the pump is working but water will not come out. No discharge will take place. If you want to take the discharge, the head will less than 140. The maximum head is 140. Then if you want to come out the water, or if the water discharge is required, flow is required, then your head will be less than 140. Okay, so this is the concept.
To push against the water and hold it as high as it possibly can within the pipe. At this point, it's just spinning the same bit of water, which isn't good for the pump, so you don't want to run a pump like this in the real world. By recording the values during the elevation, we basically get a pump curve, although I will note that pump manufacturers don't test pumps this way because it's just not practical. If you want to know how it's...
So what is the purpose of to showing this curve? Sometimes what happened, if we install the pump is running, water is lifting the surface level, but install the borewell, the water will not come out. So what is the phenomena? This is the main case. आपका जो हेड है जिसके लिए पंप बनाया गया है वो 140 है और 140 से ऊपर में आप कोशिश करें कि पंप चलाएंगे, पंप भी चलेगा, सब कुछ होगा, पानी ऊपर नहीं आएगा. You are getting? So this is the our rule. We have to think what type of discharge is required, what type of head is required. So this is the important thing.
Centrifugal pump works, then we have covered this in detail in our previous video. Do you check that out?
ये हमने पहले देखा ही है already. Now pressure head.
Head is shown on the vertical axis, and this is referring to pressure. So we often hear the term head pressure. We measure head in feet or meters, which doesn't seem correct considering we're talking about pressure.
Head का मतलब pressure है.
The pressure gauges on the pump typically reading PSI or bar. The reason for feet or meters is that pump manufacturers only know how high their pump can push a liquid. They do not know which liquid your system will be pumping. And as each liquid has different properties, the pressure will vary depending on the liquid used. However, the height it can be moved by the pump will remain the same. For example, we have this pump which can provide 125 feet of head. If we use it to pump water, the pressure will be around 54.25 psi. But if we were to use it to pump milk, then the pressure will be around 56.15 psi. And that's purely because of the properties of the two fluids.
So the pump is working on the two things. What is the formula exactly? The formula is rho, Q and H. Q is the flow rate, H is the head, another thing is rho. So this is the thing we are discussing here. If the milk is there, then it will not working like the water. The oil is there, it will be density is different. If the density is different, the flow rate will be different. So they also work on the different fluid for the different conditions.
And then plot this on the graph. This will represent.
You can see the video here. The flow rate is increasing, the head is decreasing. Head is decreasing, the flow rate is
The
increasing.
performance curve will be different for each pump, and some will suit our system needs better than others. You will usually see that as the pump flow rate increases, the head pressure decreases. When selecting a circulating pump, the pump will only perform as per the line. So, for this model, if we wanted 8 gallons per minute, then we would have 6 foot of head. You can also get multi-speed circulating pumps, which we'll look at later on in this video. When selecting a larger centrifugal pump, as long as our system requirements are on or below the performance line, then the pump can be considered. We can potentially use a smaller impeller or variable frequency drive to better suit the requirements. And again, we're going to look at that a little later in this video. For example, the performance curve of 2 large centrifugal pumps are plotted here. We need a flow rate of 30 gallons per minute and a head pressure of 70 feet. That means that pump 2 can't be used, but pump 1 could be. Impeller size.
It is another important part. If you want to increase the flow rate from the same pump, then that is the important concept. We can change the impeller and change the flow rate.
Performance details of the pump with different diameter impellers. For example, 30 gallons per minute for a 4.5-inch impeller gives us around 13 feet of head. But if we use the 5.5-inch impeller, then we would get around 22.5 feet of head. In some instances, our required flow rate and head pressure might fall between the two impeller diameter lines. In such cases, we can often machine the impeller down to the required size to get a better map. Head pressure calculation is wrong, then we do have some.
These are the criteria. You can see the impeller sizes. If you want to change the impeller sizes, accordingly the flow rate will be vary. If you want to more flow rate or lesser head, if you want to less flow rate, more head, then you can change the size of the impeller also, because it is whole upon depend upon the input energy. So input energy is converted into the performance output energy, that is the performance rho QH. If the H is less, then you can increase the head. So same pump can use for the more discharge or less head, or higher head for the less discharge. So one part is this. Another part is the efficiency point of view. If you want to increase the efficiency of the same pump, then what efficiency you are you can understand what is the meaning of the efficiency? Output upon input. So what is the our objective, being an engineer, being a good practice, we want to apply this pump technology, then we want to more efficiency. So maximum efficiency is the 73%. There is a curve like this, 72, 65, 50. So this is the important part. If you want to maximize the efficiency, then it is not possible you gain the maximum head. So optimize both the parameter, optimize the head or head. So this is the part you can see
pump
here.
casing increases, and that will allow water to recirculate in this
Their
region.
impeller is smaller size, their impeller is higher,
The efficiency is the ratio
bigger diameter
between the amount of energy going into the pump versus the amount of energy we get out of the pump. So ideally, we want this to be as close as possible to the peak for optimal performance. The pump will always lose some power when it converts and transmits this electrical energy into mechanical energy. And this will be lost through the couplings, the bearings, the shaft, the seals, the cooling fan, etc. For example, on this chart, we can see that if the pump provided 125 gallons per minute at 25 feet of head, then it would run at around 67% efficiency, which isn't very good. If the same pump operated at 30 feet of head for 138 gallons per minute, then it would operate at its peak performance.
there are the two examples are there.
73.
One is the head is 20 meters and discharge is 125 gallon, or you can say the 7.58 liter per second. So then this option will choose, then the efficiency comes only the 67%. But the same pump, if you opt this option is the head is like in between, means 125 to 140, or then in that case you got the height of the or discharge height, head is the 30 meters, that is the efficiency is 73%. So optimizing these parameters play an important role. If you utilize your system effectively, that is one of the part we can understand here. So this is the purpose of to showing these pumps. Now another part of this presentation is submersible pump. The working of the submersible pump and centrifugal pump is almost same. The concept is here also centrifugal effect, and in this centrifugal effect we will only the thing in centrifugal pump, the priming or you can say the cavitation is the issue. But if we go for the submersible pump, as per the name, it is the submerged in the water, it is not on the surface. You have to put your pump on the ground level, or you can say the bore bell or your bell. So then that is there is no suction head is required, only the delivery head is required, because the water pump is only the water. But centrifugal pump, both head will work, suction head and delivery head. Okay, so that is the major difference. The submersible solar pumps are particularly well insulated areas and limited access to the surface water sources, or when the traditional grid power pump is not feasible. Particularly what are the application where the grid is not available, we want to apply the solar pumps, or if the grid is available, then we can supply this electricity in this submersible pump. So there are the, you can see here 1 2 3 4 like this, these are the structures. These structures is the different impellers. These impellers based on the one shaft, and the shaft is rotate through the electrical energy, it will be supply the water. So next part is, this is the whole system. If we supply the electricity from the PV panel, then controller, if the distance from the submersible pump to controller is high, then we have the one control unit near the panel, that is the main system of the submersible solar submersible pump. And these are the main components similar to the centrifugal pump. There is the photovoltaic solar panel, is required, PV panel is required, then pump in place of the centrifugal pump, submersible pump is used, charge controller and battery tank, battery bank is optional. If we use the direct grid, then there is no battery bank is required. If you run to the without that, you can see the submersible pump generally using in the our agriculture. So please see the small video on the submersible pump also, then we will see the other performance parameter.
Recently, submersible pumps have gained good market shares in both the industrial and domestic sectors due to their high versatility and reliability. They need no priming, they are not prone to the issue of cavitation, and are very efficient. The submersible pump is a centrifugal pump. You can see how the impellers are throwing the water outwards. The impeller blades are the backwards curve type.
Similar to the centrifugal pump, the
Here,
backward type
many of the
blades are
impellers
used.
are connected onto a single shaft, and this shaft is driven by an induction motor. The water enters through the eyes of the impellers, and they are then thrown out radially due to centrifugal action. This way, the water particles gain both kinetic and pressure energy. Now we need to pass this outlet water to the next impeller efficiently. A stationary device called a diffuser is used for this purpose. You can see how the water flowing from the impeller enters the diffuser. The diffuser then deflects the inlet water and makes it ready for the next impeller stage. The next impeller is connected to the outlet of this diffuser. The series of connected impellers multiplies the pressure gain at each stage. This is the reason why submersible pumps produce a huge amount of pressure head.
So this is the important part. If you want to the pressure, maximum pressure, more pressure, number of the submersible pump or stack of the submersible pump is required. If the head is low, then only one or two stages are required. If the head is more, then we can increase the number of stages, number of the centrifugal pump or number of the impellers. If you increase the number of impellers, obviously the input power is required. The panel size, PV panel size is more. If the using the small head, small discharge, then the number of impellers is less and the PV panel is also less. So as per your requirement, as per the conditions and discharge, we can use the number of impellers here. So
the water, so pumped, passes through an inbuilt non-slam check valve of the submersible pump. The issue of water hammer is effectively reduced by the non-slam check valve, which is a huge issue in high-altitude pumping. Now let's focus on the prime mover of the submersible pump. Generally, an induction motor is used to run the impellers. The power supply to an induction motor is given to the stator, which can be either single-phase or three-phase. The motor produces a lot of heat during operation, and due to this reason, the motor is either water or oil-filled for effective cooling. The continuously circulating coolant jacket around the motor makes sure that the motor never overheats. You can see how a small impeller at the bottom maintains this circulating flow of coolant. The entire impeller motor assembly is immersed in the working fluid. This means that just as with conventional centrifugal pumps, priming is not needed in submersible pumps. Another major issue faced by normal centrifugal pumps is the issue of cavitation.
so both issues are
One
eliminate
of the
priming
main
and
reasons for
cavitation.
this happening is the low pressure on the suction side. In submersible pumps, the water is pushed rather than pulled, and this reduces the chance of a negative pressure head in the system, and thus the issue of cavitation does not occur. The high pressure head, flow rate characteristics, and the ability for it to be immersed completely in the water makes submersible pumps an ideal choice for bore well lifting, firefighting, and oil well lifting. 90% of the oil wells in the world require some kind of artificial lift to achieve an economic flow rate. There is no narrow flow region in the impeller and diffuser section of submersible pumps, and this fact also makes submersible pumps the ideal choice for wastewater pumping and lifting highly viscous fluids. Moreover, with a specialized design, submersible pumps can be even used for slurry pumping.
So this is the about the centrifugal pump. The working is quite similar to the so what are the major two disadvantages we address in the submersible pump? One is the priming. What is the meaning of priming? You heard about when the water is not pump is not flowing the water, then we will pour the water in the this impeller. That pouring of that water, or you can say the removing of air from the impeller, is known as priming. So priming is not required in the submersible pump. Another thing is cavitation. The what region of the cavitation? The cavitation is due to the air bubbles. So air bubble will not never come because it is the already submerged in the water. So these two things we have addressed in the submersible pump, and these are the advantages of the renewable energy, reliable water supply, cost saving, and easy installations. Then submersible pump, if you have the bore well, you directly pour in that, and that is easily you can install. And application point of view, agricultural, and residential use, disaster, community water supply, there are the number of applications you already gone through the previous lectures. But installation and maintenance considerations, there are the important thing. If we want to install anywhere, there is a first thing is the site preparation to ensure the installation site to level the and clear access of the sunlight, proximity of the water sources, and distribution network. These are the important thing. So first important part is the site preparation. Another is the professional installations, means the rely on the experience and technicians properly installed to solar panels and water pumps necessary to electrical and plumbing components. So one is the PV panel side, another is the centrifugal side. To centrifugal side, you have to know about the what is the head is required, what is the discharge is required, what type of panel we have to install. So these are the important professional skills are required. Another important part is the maintenance. The routine maintenance is required. Regular inspection and cleaning and major adjustment can be maximize the system efficiency. If you take the preventive maintenance after 1 or 2 months, then it will be a life of the pump is more. In this case, if you want to the things you can apply with the help of the wiring, or you can say network remote monitoring, you can apply from the your room. So this is another integrated sensor or Wi-Fi, or you can say the machine learning you can apply here. Financing and incentives of the PV panel, already I think most of the expert discussed the financing and incentives about it, and but the major part is reduced operational cost, average upfront installation cost if we see the proper scheme, and government incentives and rebates are there. Lot of every country be providing the incentives, as well as the payback period in terms of how much cost we are applying on the installation of this pump. So that cost can recover within 2 or 3 years as per your requirement. This is the another application you know about the drip irrigation system that can use in the submersible pump with the help of the overhead tanks. Another part is the future trend. So if we want to integrate with the control, or you can say the intelligent control and remote sensing, then it is the one of the feasible solution. And with the help of the AI, you can optimize the head and discharge. If your discharge is required more, then what is the meaning? Discharge is you can uh, reduce the head or reduce the power output with the help of the artificial intelligence, or you can say the machine learning. You can get the data, and that data will be reduce your power output and reduce that, or you can say the excess power you can store in the battery. Another part is the integrated management system. This system you can install for whole farm, whole agricultural land, with the help of the if we integrated means whole system will be based on the your programming and optimization. So PV water pumping technology continues to evolve. We can expect this increasing sophisticated systems and that leverage intelligent control, and that control with the help of the Wi-Fi. If you can access these things with the help of, or you can control with the remotely. So remote monitoring, energy storage, AI powered optimization, these are the advancements. If you think about this technology, then the future is bright in this direction, and you can this whole system for the better or smart agricultural applications. We have discussed the finances and incentives in the previous slide also. Now the advantages, or you can say the evaluation of the pump motor, there are the lot of avenue is there. We have discussed about the solar energy, and we have discussed about the centrifugal and that part. So proper efficiency and visual frequency drives and all the intelligent control can increase the effectiveness of the system. So in this behalf, that from the my side, that is you can reduce the maintenance and downtime with the help of proper conditioning, condition monitoring, as well as the uh, routine maintenance, or you can say the preventive maintenance. That is the important part that can be covered in the, if you want to increase the side. So finally, advanced connectivity and automation, there are the three major advancement you can say. One is the remote monitoring, another thing is the predictive maintenance and integrated control. If you want to the advancement in this direction, these are the three heads. Remote sensing, because if you want to work multiple places, then you have the one of the option. You can integrate with the internet and run the pumps as per your requirement with the help of the sensing devices, sensors. And but at the same time, the system will run effectively if we provide the preventive maintenance or predictive maintenance after 2 month, 3 month. Every maintenance is required in this direction, and integration of all the technologies is the important part. Another losses in point of view, you can say the noise and the vibration reduction is one of the area, or there you can do the work in the pump technology. In the submersible pump, lot of advancement is going on in the submersible pump. Noise is almost reduced, but if the noises work audible, or you can say the vibration will take place, then it is the signal of the preventive maintenance. So this is the one of the thing, or acoustic you can say apply. Environmental consideration point of view, the energy efficiency is, we can increase up to the 50% as the available desired data. However, we are using 15 to 20% efficiency. So that is the one of the scope where we can do the work. The important energy efficiency modern pump motor led to the substantial reduction in the greenhouse gas emissions as well as the energy consumption. Another thing is the reduce the waste. Obviously, the fossil fuel and the electricity is not utilizing the, we can reduce the load from the environment. And recyclability, advanced material can use to developing the PV panel or the pump components, then can be one of the area we can use the recyclability of the these panels. Finally, these are the future trend. I have already discussed the intelligent control, energy storage, remote sensing, AI powered optimization, and the integrated water management system. So if we, it is whole one of the course where we can apply these things. And if we apply the AI, then it is the more fruitful and more economical. The payback period may be reduced 3 years to 1 year if we use this type of system. So in the conclusion, we can say the growth is more. In this case, the global solar market is expected to grow of 30% annually. From 10 years data we have, the growth is more than 30%. And over the 50 million solar water pumps are projected to install worldwide in 2030. It is the Global Solar Alliance. We have take the oath or the mandate. Another is the cost saving. The solar pump can reduce the cost saving up to the 75%. That is the important part. So as the demand is more efficient, reliable and environmental friendly, equipment continues to rise or to continues our growth, and the pump motor industry is poised to witness even the more remarkable and advancement. So this is the outcome of this today's lecture. If we work environment friendly, means PV panel based, reliable and efficient. Efficient we have discussed about the water pump performance efficiencies, and the integration of the cutting edge technology means AI, machine learning or remote sensing. These are the technology can pursue the sustainable manufacturing processes, and future pump technology hold the vast potential. So lot of the things in this note or in this remark I have completed here. You may ask some questions regarding this. So any query regarding the pump performance or the head of you can say the conversion of the head energy to the you can say the kinetic energy to the potential energy, that is the important part. Being a if you want to install the pumps, that is the technical part is also important. So we have tried to discuss about the pump efficiency or impeller design, cavity design and the integration of the motor to pump. If we know about the pump output, then we can install the motor. If the motor is less capacity, the power pump output is more, then maybe after some time the motor can burn. Or the motor is high capacity, a pump is low, so the effective utilization of pump will the motor will not take place. So this is the crux of this today's lecture. So you have to integrate both the things. PV panel. PV panel means how much capacity of panel is required, the capacity of pump is required. That is the part. Okay. So you may ask any question if you have. कुछ समझ में भी आया थोड़ा बहुत जो बताया गया? हालांकि
such a very nice lecture and informative presentation. So we are privileged to present a bouquet to our speaker. So
अरे थैंक यू सर, थैंक यू.
आइए जरा इधर आइए और ये सामने आते हैं.
थैंक यू.
पानी निकलो.